Now we're going to move on to video 10, which is combustion reactions. So turn to the page in your booklet that says combustion reactions at the top. A combustion reaction is when a hydrocarbon, so that's this, it's a carbon-hydrogen compound. The X and the Y mean that these are subscripts, so it could be C2H4, C3H8, C5H12, etc. Plus O2, which is oxygen gas, yields, and we're going to often produce energy as heat and light, as well as carbon dioxide and water. So these reactions often involve hydrocarbons. When hydrocarbons react with oxygen, the products are always CO2 and H2O. When balancing combustion reactions, you're going to balance it in this order: carbon first, then hydrogen, and oxygen last. If you end up with an odd number of oxygen, then we're going to multiply the coefficient by 2 and rebalance the equation. So here we go. In this first example, we have 2 carbons on the left, 1 carbon on the right. So in order to balance it, you would put a 2 here. Now I have 6 hydrogens on the left, 2 hydrogens on the right, so you would put a 3 there. So carbons check, hydrogens check. Now we're on to oxygen. And on the left side we have 2. But on the right side we have, and I'll do this in another color for you, 2 times 2 is 4 plus 3 equals 7 oxygens on the right hand side, which is an odd number. So because we have this odd number, you can put a 2 in front of the entire equation and then rebalance all over again. So now that I've put this 2 in front, we're going to say 2 times 2 is 4 carbons, so I need a 4 here. And then 2 times 6 is 12 hydrogens. So over here I need a 6 because 6 times 2 will be 12 hydrogens. And now for oxygen, we have 2 on the left, and on the right you have 4 times 2 is 8 plus 6 equals 14. And so here I can put a coefficient of 7 because 7 times 2 is going to give me 14 oxygens on the left to match the 14 that are on the right. And so your final answer is 2, 7, 4, and 6. Important to realize that you will not always have to do this. You will do this if you end up with an odd number of oxygens on the right side. So if you end up with an odd number of oxygens on the right, put a 2 there and then rebalance. But you might not always have to do that. You might end up with an even number of oxygens. Let's balance these combustion reactions that you see below. To predict the products, easy. It's always the same 2 products, CO2 and H2O. So we have 3 carbons on the left, which means I need 3 carbons on the right. I have 8 hydrogens on the left, so 4 times 2 is 8 hydrogens on the right. And now I have 2 oxygens on the left. If we add up our total number of oxygens on the right, we have 3 times 2 is 6 plus 4 equals 10. Good news, that's an even number. So 5 times 2 will give me my 10 oxygens on the left side. So we have 1, 5, 3, and 4. Okay, let's look at the next one. We have C4H10 plus O2. This is a combustion reaction, so it has the same 2 products, CO2 and H2O. We're going to put our blanks for our coefficients. And now let's balance it. 4 carbons on the left, 4 carbons on the right. 10 hydrogens on the left, so 5 times 2 will give me 10 hydrogens on the right. 2 oxygens on the left. 4 times 2 is 8 plus 5 is going to equal 13 oxygens, and this is an odd number, which means we're going to have to start all over again by putting a 2 in front of here and then rebalance everything. So I'm going to white out my 4 and my 5. Using a pencil is a good idea. So now 2 times 4 is 8 carbons. 2 times 10 is 20 hydrogens. So over here, 10 times 2 is 20 hydrogens. And now we have 2 oxygens. So 2 times 8 is 16 plus 10 is equal to 26, which means I need a 13 there. 13 times 2 is 26. Now, let's do the third one. We have 6 carbons. Oh, I'm sorry. We need to write our products. This is a combustion, so it's the same products. CO2 plus H2O. We're going to put coefficients in front of each of these. 6 carbons on the left, 6 carbons on the right, 6 hydrogens on the left. 3 times 2 is 6 hydrogens on the right. And then finally, we have 2 oxygens on the left. But on the right, we have 6 times 2 is 12 plus 3 equals 15. That's an odd number of oxygens. So I'm going to show you a trick. We said that when you have an odd number of oxygens, put a 2 here, but guess what? That odd number is also this coefficient for oxygen. Because if you recall before, we got 13 oxygens, and then we had to double everything. Well, this was 13 to go with that odd number. So now I'm going to white out my 6 and my 3, balance them now that I have this 2 here. 2 times 6 is 12, and 2 times 6 is 12 hydrogen, so I'm going to need 6 times 2 makes 12 hydrogen. So we have 12 carbons, 12 hydrogens, and if you want to do the math, we have 24 plus 6, which is 30 oxygens, and half of 30, so 15 times 2 is 30 oxygens. So you see how that worked out, where this odd number ended up being the coefficient in this spot right here. Okay, this last example is special because we have oxygen in 2 places, there and there. So first, let's write our products. It's still a combustion because this is a hydrocarbon, even though there's also an oxygen there. It's a hydrocarbon plus oxygen. So our products are CO2 and H2O. Now, I have 1 carbon on the left, 1 carbon on the right, a total of 3 plus 1 is 4 hydrogens on the left. So 2 times 2 will give me 4 hydrogens on the right. And now I can add up my oxygens. This is tricky because over here I have a single oxygen there and 2 oxygens here. On the right, I have 2 plus 2 equals 4. And normally that wouldn't be a problem, but it's a problem today because that 1 oxygen there means that I have 1 plus 2 equals 3. That's messing everything up. So I really want to go ahead and get rid of this odd number here. And to do that, I'm going to put a big old coefficient of 2 in front of there, just like I did in these other examples. So now I'm going to rebalance everything with that 2 there instead. And so I have now 2 carbons on the left, so I need 2 carbons on the right. I have 4 times 2 is 8 hydrogens. And so over here, 4 times 2 will give me 8 hydrogens. And then finally, let's check our oxygens. We have 2 plus 2 is 4 oxygens on the left. We have 2 times 2 is 4. And we have 4 times 1 is 4. And together those make 8. So over here, what can I do to make this equal to 8? Well, I have 2 oxygens there. 2 plus 6 would be equal to 8, right? So we have 2 oxygens there. If I put a 3 here, 3 times 2 will make this 6, and this 2 plus this 6 will equal 8. This is quite a challenging balancing, and if we're lucky, we only have 1 or none on our test. You should be able to turn to page 19 and do homework part 7.